So this lesson is on slope of a line, and slope is really important, and it's got a lot of moving pieces, a lot of different ways that it can be interpreted. So there are going to be a lot of slides. About half of them are just going to be like definitions and things like that. But I want to make the connection to slope is something that actually shows up a lot in real life and is very useful. So first, let's look at the definition of a linear equation in two variables, because one of the things we're talking about this week, we're learning about functions, we're learning about linear functions, and a linear function is an equation, two variables. And basically, when you graph it, because you have two variables, x and y, you get a line, hence the name linear. And all linear equations have no exponents on the variables. So we've been solving different types of equations in one variable just for x, essentially, with linear and quadratic, radicals, rational. We've done a whole bunch of solving. Those are all one variable. Everything we're moving on this week forward is all two variable stuff. And so what makes something linear in two variables is still the same thing that makes it linear in one variable. There's no exponents on the variables. Now, what's different about a linear equation in two variables versus one variable is that there are technically infinite solutions. So you don't really solve something that has both x and y, because you can't get one number because you've got two variables. So you're trying to look for multiple numbers. You can only solve if you're told a number for x or y and you're looking for the other one. But if you're trying to find both x and y, there are multiple ways that you can make those work in an equation. So there's technically infinite solutions. So when we have things that are two variables, we tend to look at them graphically versus solving like we've done for the first half of the class. So we're focusing on linear equations today because slope is a specific property of these type of equations. So you have to kind of have some basic knowledge of what you're looking at to understand what we're doing with slope. So the standard form of a line is ax plus by equals c. So it's just we usually have all the variables on one side of the equation to make it standard form. And we have an x or y. There's no variables on there. Other forms of a linear equation, and these are the important forms because they both involve slope, which is what we're talking about today. There's slope-intercept form and then point-slope form. So those are the two most common forms of a line. Standard form of a line is actually not very common. It's usually in slope-intercept form. That's the most common way you'll see a line. And so slope is a property of both of those things. Now, we're not going to be worrying too much about the equations of a line. We're focusing on just what slope is, what it means, how to calculate it. So what exactly is slope? So slope is a numerical value. So it's a number used to indicate, and I see that I accidentally, that should be singular, indicate, used to indicate the amount of slant of a line. So it's a number that tells you how slanted a line is, and it also gives you the direction. And we always look at direction going left to right, whether it's going up as you move left to right, or is it moving down as you move left to right. It is not the same thing as angle. So a lot of people get confused and they think slope and angle are the same thing, and they're not. Slope is concerned with vertical and horizontal distance. An angle is concerned with the space in between your line and a horizontal. So they're looking at two very different things, and they're related because you can find the angle if you know the slope, but they're not the same thing. And so for those that have to go on to pre-calculus, this is something that I've seen a lot of people get confused on, because once you get to trig, you're trying to find angles, and some people give the slope instead. They're not the same thing. So slope is just a number that tells you how slanted something is. Most of the time it's unitless, but it does have units in some circumstances. Now, angles always have units of degrees. So slope is different in that aspect, is that sometimes it has no units at all because the units cancel out. So the key point is that the slope, because it's measuring the amount of slant, it's measuring how steep a line is. And so generally, the larger the number is, the steeper the number is. And we just ignore if it's a positive or negative number. If you just, took the absolute value, you just look at the number and ignore the sign, the larger it is, the steeper it is. And then we've got slopes that can either be a positive or a negative number. And this is what indicates the direction. So positive means it's going up as we move from left to right. So it's increasing. And then a negative slope means it's going down as you move to left or right. So it's decreasing. And so a negative meaning decrease makes sense because subtraction is like adding a negative, which you're making things smaller. So if you think of it in terms of like, positive, you're adding, yes, you're going to increase, you're going to get bigger. So the sign tells us the direction, whether we're going up or down, and then the number itself tells us it's a measurement of how steep our line is. So the equation for slope, and this is something, if you've got a formula sheet, you're going to want to put this in your formula sheet. So we use M to represent slope. That is the symbol that we use for slope, is the letter M. And there are lots of different ways you can define slope. So you can see I've got 4 different ways that I have here. So sometimes you'll hear slope defined as rise over run. And that essentially means how high are you going and then how far over are you going. So it's basically how far up and then how far to the right. So that's basically, if you look at an X or Y, you're looking at your change in Y, which is the rise, over the change in X, which is your horizontal distance. And so and shortcut to writing that is with these delta symbols. So you see the little triangles. These are actually the Greek letter delta. It's a Greek alphabet, one of the letters that comes from Greek, and it just means change. So in math, instead of writing change, we'll just use delta. So it's just a shortcut for the word change as we use that symbol. So another way to think of change is the difference. So really what it is we're looking for the difference between two Y values, and then we're dividing by the difference in the X values. And so we're subtracting them. And this gives you the distance between the 2 points, basically. So you're looking for the distance it moves in Y over the distance it moves in X. So if I drew X, Y, and here's my line, and it's on an XY grid. So I would have some point. You need 2 points in order to determine the slope, because you need to find the distance between those 2 points. And essentially what we're doing is we're just getting a little triangle formed there. And then the slope is measuring this vertical distance, which we're just calling the change in Y. And then the horizontal distance, which is the change in X, and then you're dividing them, and it's always Y over X. So that's what slope is we're measuring essentially, if we were to make a triangle with those 2 points, you're measuring the difference between the X values and the difference in the Y values and then dividing them. So the way we write these points is X1, Y1, and then X2, Y2. And the numbers that are below, these are subscripts. Subscripts are labels. So it's different from an exponent. An exponent, you have the number above the thing. When it's below, it's a label. And so these are just labeling the first ordered pair and then the second ordered pair. So that's why we're using 1 and 2. And we usually label them like left to right on our graph. So to find the slope of a line, you need 2 points on that line. And you can use any 2 points, just as long as there's 2 points on that line. And then you're finding the distances between the x values and the y values, and you're dividing them. And so I sort of was taught y's up, because if you're trying to remember, well, which one goes on top, the y goes on top, y's up, if you say it out loud. So the y is on top, just like on our graph, on an xy graph, y is the part that's going up. So if you just kind of match your fraction with what's on top of the fraction is what is on top of the graph, which is the letter y, then you'll get the order correct, and you'll get y over x, or the change in y over the change in x. So that's our slope formula. I'm not going to go into how that formula comes about. You know, that's something you can research on your own if you're wondering how we came up with that formula, but that's the formula. So when you're looking at slope in terms of its letter, the absolute value of that number is basically, you know, as that number gets bigger, the steeper it's getting, because it's the steeper a line gets, the larger the gap in the y values. So if I was to compare this to a different line, if I drew a purple line here, the purple line is steeper, and because it has a bigger y, the change in y, than the change in x. And so that gives it a bigger slope, because the y is changing faster than the change in x. So we can have slopes that are undefined, and that's what happens if you're dividing by 0. So here, if you have your slope and it's undefined, you're going to get 0 in the denominator, which means there's no change in x, or your difference between the x values is 0. So if your x value is not changing, it's a vertical line, because you've only got the y that is changing. And you could think of that sort of like an infinite slope. It's going up, the y is going as high as it can, essentially. Now the opposite would be getting a slope of 0. And so if we have m equals 0, that is where you get 0 on the top of the fraction. And so that means there's no change in y. So if the y is not changing, this gives us a horizontal line. And so there isn't a slant. So those are 2 special values for slope. You can get undefined or 0, and those mean specifically a vertical or horizontal line. And then the next 2 bullet points are basically the sign. If it's greater than 0, it's positive. It's increasing from left to right. If it's less than 0, it's negative. It's going down from left to right. And then if you're curious, there's a website that actually goes into why the letter M is used. You can read that on your own time when you download this PowerPoint. Are there any questions so far? I feel like this page might be the one that has the most questions, if there are questions. Okay, so there's a lot more to know about slope. It's a very, very big concept. So, you know, I've been talking about, I gave the formula for slope, and I've been connecting it to these lines. And so I just want to connect that, you know, more explicitly. So the first picture on the top here is coming from the textbook. It's coming for if we have a slanted line, either with a positive or a negative slope, that's it will have an equation with both x and y. So if you have an equation with both x and y, and there's no variables, when you graph it, it's going to be slanted. Now, if you're given an equation with only y in it, that is automatically going to be a horizontal line when you graph it. And so that has a 0 slope. And if you have an equation with only x in it, then that is going to be a vertical line, and that has an undefined slope. So if you're looking at equations and you're asked what the slope is and you only have one variable, you have to determine, do I have an x or a y? And then that will determine and tell you which, if you have a zero slope or an undefined slope. And what I usually do is I graph it, and then that helps me determine what kind of, graph it is. And if you're confused, well, how do I know that a horizontal is y versus x? So if we put this on just our xy plane, where we're graphing, a horizontal line is going through the y-axis, and that's why it's a y equals equation. While the other side, the x equation is going through x on your axis, so that's y. So a vertical line goes through x, that's what makes it vertical. So if you get confused on x or y, because you might think vertical is y because y goes up, but it's not what does the axis do, it's where does it cross? Does it cross the x or the y? And then that determines what kind of line it is. But you can use this on your note, you've got this in your notes, it's in the textbook, you can use it on a quiz, so you get confused, you can always look this up. So that's positive, negative, zero, undefined slope. Other types of things that we can do with slope is we can compare lines to see whether they're parallel, perpendicular, or if they're not either one of those, because lines don't have to be one or the other. They could have different angles between them. So parallel lines don't intersect, and in order for them to not intersect, they have to have the same steepness, which means they have the same slope. And so the slope of one line is equal to the slope of the other lines. That's why it's M1 equals M2. The 1 and 2 are just labels. So parallel lines don't intersect, they have to have the same slope. That's nice, because if you're looking at equations and you have two equations with the same slope, you automatically know they're not going to intersect. Perpendicular lines intersect, and they intersect in such a way that there's, they form a right angle. This is 90 degrees between them. And in order for that to happen, their slopes have to be in opposite directions. And then their steepnesses are not exactly the same. And there's a special product or equation that is true. So slopes are perpendicular, lines are perpendicular, if the two slopes multiply to -1. Well, what this means is that they are opposite in sign, and one is the reciprocal of the other. So that is a particular property of perpendicular lines, is that they are opposite reciprocals. And then if they don't fit one of those rules, then they're just regular two lines that intersect. Their steepnesses are different. They may or may not be going in opposite directions. Either one could be true. They're still intersecting, but they just don't have that right angle. So if you're ever asked whether lines are parallel or perpendicular, you need to look at the slopes, because that tells you. You can't just eyeball it on a graph, because you could have lines that are almost perpendicular. So perpendicular would be 90 degrees, maybe it's like 89 degrees. If you eyeball that, you'll say, oh yeah, that looks perpendicular, but maybe it's not. So you have to actually see, do their slopes multiply to -1? So those are some special properties of slopes and how they're related to different types of lines, parallel, perpendicular, that sort of thing. Any questions? Okay. So slope is a big concept. And in addition to everything that we've talked about so far, slope has a meaning in real life, and that is generally called the average rate of change. So it's called the average because it's basically the amount you're going up over some amount of time. So you're just kind of averaging the distances in a way. Rate of change, because you're looking at the change in y over change of x. So it's changing, and then rate usually means you're dividing things. So literally the formula is rate of change. And then that average kind of comes by, if you think of an average, when you're taking the average of something, you divide by how many items you have. In this case, maybe how many X values did we move? You can think of it as the average in that case. So slope is called the average rate of change. And for those of you that are going on to calculus, calculus is the study of rates of change. So everything you do in calculus, you're looking essentially at slope. You're just not looking at it at only lines, but you're looking at how things change when they're not lines, if they're curved, if there's different shapes. But it's basically you're taking the idea of slope and then you're expanding it and looking at a broader picture. So calculus is all about rate of change. And we're just getting a little tiny bit right here. There are a lot of things in real life that are slopes. So anything that is a rate where you have something divided by something. So any speed, that is technically can be considered a slope if you were to write an equation and to graph your speed or something. Miles per hour, kilometers per hour, feet per second, anything like that, that is a slope. And if you think of your formula, D equals RT, that R, that is your slope, because R is your rate, your speed, and this is actually in slope-intercept form, but with different variables. So when you start going into slope-intercept form, you'll see, oh, that is literally the slope. Other types of slope, anything that's cost per time. So if you're getting, like, if something costs some dollars each month, you know, like your phone bill, your salary, maybe you get paid per hour. So anything like that is considered a slope. So anything that's changing over time, those are slopes. So you could write an equation for costs where you have a fixed cost and a variable cost, and that would be a linear equation. You can write an equation for salary. Maybe you have a base rate that you earn plus some dollars per hour. That can be linear, that there is a slope, because if you were to graph your data, there, it would form, because it's changing by the same amount per hour. If you were to graph your salary, or, in one day you're earning, say, $10 an hour. So you've got 10, the next hour, after 2 hours, you're at 20. If you graphed that, so, 10, 20, 30, if you graphed how much you would earn in a day, it would make a line. And so that slope is how much it's changing over time. So anything with a unit where you're dividing like that usually is written as a slope in a linear equation. Ratios, because you've got dividing, if you're comparing two things, you've got dollars per ounce. If you were to look at that, that's considered a slope because it's a rate of change. Cups per serving, anything like that. So other things are pitch of a roof. So if you go back, or if I go back to my little triangle that I had here, when you're figuring out pitch of a roof, you're basically looking at your beams and that vertical distance over the horizontal distance, and then you get like a pitch, and it's a number. It's usually a fraction. That is a slope. That's what pitch is measuring. It's literally measuring the slope of the roof. And then grade of a road, that's another one. The grade is usually given as a percent, but it's the same thing. They just calculate slope and then they turn that number into a percent. But it's literally a slope. How much are we changing vertically divided by how much are we changing horizontally? So these things are, they're there in real life, and you're working with slopes. You just have no idea because it's never been defined as such. So things you can do with slope. You can compare the steepness of two lines, because you just compare their slopes. You can determine if the direction of a line, whether it's going up or down. You can determine if two lines are parallel or perpendicular. You can compare rates graphically and numerically. So you can compare like salaries and things like that by graphing them. Or, if you don't have an equation, you can graph the data and you can kind of get a slope from there. You can find average rates of change, and you can graph a line as long as you know what the point in the slope is, and you can graph it without having to figure out individual points. You just need one point in the slope and you can graph everything from there.